We're going to evaluate the integral of x to the 3/2 times inverse tangent of square root of x. So first, let's use exponential notation here and rewrite this as the integral of x to the 3/2 times inverse tangent of x to the 1/2. We're going to use integration by parts. So let u be inverse tangent of x to the 1/2, and then du is equal to, in the denominator we have 1 plus x to the 1/2 squared, which is 1 plus x. In the numerator we have the derivative of x to the 1/2, which is 1/2 x to the minus 1/2 dx, and we can write this as 1 divided by 2 times x to the 1/2 times 1 plus x dx. And that means that dv must be x to the 3/2 dx, and we can take the simplest antiderivative, that is v equals to 2/5 times x to the 5/2 power. Now let's go ahead and bring back our integral, the integral of x to the 3/2 times inverse tangent of x to the 1/2. This is our integral of u dv. It is equal to u times v, or 2/5 x to the 5/2 times the inverse tangent of x to the 1/2 minus the integral of v du, which is going to be 1 divided by 2x to the 1/2 times 1 plus x times 2/5 x to the 5/2 dx. So you can see that we can cancel the 2's. X to the 5/2 divided by x to the 1/2 is x to the 4/2, or x squared. So we can rewrite this in a simpler way. We have 2 over 5 x to the 5/2 times inverse tangent of x to the 1/2 minus 1 over 5 times the integral of x squared divided by 1 plus x dx. So all we have to do is evaluate this integral on the right, and the problem is solved. I'm going to leave off the coefficient 1/5, evaluate the integral, and then come back and multiply the answer by 1/5. So we want to evaluate now the integral of x squared divided by x plus 1 dx. We'll do that by substitution. Let w be x plus 1. dw is dx. X equals to w minus 1. X squared equals to w minus 1 squared, or w squared minus 2w plus 1. Let's rewrite this integral in variable w. It becomes w squared minus 2w plus 1 divided by w dw, and this is the integral of w minus 2 plus 1 over w, and so we have 1/2 w squared minus 2w plus natural log of absolute value of w. Let's replace w with x plus 1, and we have 1/2 times x plus 1 squared minus 2 times x plus 1 plus natural log of absolute value of x plus 1. Let's simplify this further. This is 1/2 times x squared plus 2x plus 1 minus 2x minus 2 plus natural log of absolute value of x plus 1. And so this is 1/2 x squared plus x plus 1/2 minus 2x minus 2 plus natural log of absolute value of x plus 1. And this is 1/2 x squared minus x minus 3 over 2 plus natural log of absolute value of x plus 1. And we're done with the second integral, or the integral on the right. Now we return to the original integral. We had the integral of x to the 3/2 times inverse tangent of x to the 1/2 dx. It is 2 over 5 times x to the 3 over 2 times inverse tangent of x to the 1/2 minus 1/5 times the integral of x squared divided by x plus 1. We just evaluated this integral, so this is 2 over 5 x to the 3/2 times inverse tangent of x to the 1/2 minus 1/5 times the quantity 1/2 x squared minus x minus 3/2 plus natural log of absolute value of x plus 1. And let's add a constant. Let's call it C1. We'll modify it in just a minute. And so all we have to do is simplify it just a little bit, and we're done. So this is 2/5 x to the 3/2 times inverse tangent of x to the 1/2 minus 1 over 10 x squared plus 1 over 5x plus 3 over 10 minus 1/5 natural log absolute value x plus 1 plus C1. Notice that 3 over 10 is just a constant. Combine that with C1, call that new constant C. And now our final answer is the integral of x to the 3/2 times inverse tangent of square root of x is equal to 2 over 5 x to the 3/2 times inverse tangent of square root of x minus 1 over 10 x squared plus 1 over 5 x minus 1 over 5 natural log absolute value of x plus 1 plus constant of integration C.